Hello everyone, today in network programming we are going to talk about multi-process programming, which includes fork and pipe. Compile the program above and note the output. This example contains a few mistakes, so we can compile the program. The program contains fork. Fork is a system call that causes the current process to split into two processes. In order to start, we need to include all the necessary library into our program, declare our PID and RV as our variables. As you can see here, PID does not equal to fork. So if the case is -1, which is false, it will produce an error message and it will immediately exit. Parent will exit, but if it is case 0 or true, it will produce the child output. The child said, this is the child process. My PID is get PID will automatically generate the PID for the child and the parent's PID, and it will obtain its parent's ID, and it will produce an exit status for itself, and then it will exit. This parent process will be produced as default, and it will show as the output as well. The parent will wait for the child ID, and it will produce, and it will show the child exit status here. After the parent show the child exit status, then the parent will exit as well. The parent will return the exit status of the child here. After that, the parent will exit as well. This is the child process and the parent. After the child show its PID, the parent will wait for the child to exit. The child will show its PID and its parent's PID, and we need to enter the child's exit status. We can choose any number, and after the exit status is entered, the child will exit. The parent will return the child exit status, and the parent will also exit. The next output will be pipe. This is the example which contains a few errors. Initialize BFDS with array size of 2. BFDS is a pointer to an array of 2 integers to hold read and write file descriptors. The size of 30 for char buff. If it is false, it will produce the error message pipe and it will immediately exit. Create this process. It will produce writing to file descriptor as the output. The PFDS1 is for the program to write. It produces this output and with the size of 5. And then it will prompt the user to read, and it will produce the output reading from file descriptor. 0 indicates read, the output we want to produce with the size of 5, and then it will produce read. It is writing to file descriptor 4. Any value from this is produced from this. Reading from file descriptor 3 is obtained from here. Read test will be obtained from here, read, and it will take this test. The next example will be fork and pipe. The pointer to an array of read and write file descriptor is 2, and the size of char buff is 30. If fork is false, it will immediately print the child process, child writing into the pipe, and it will write test with the size of 5, and then the child will exit. Or else, if the fork is true, the parent process will be the output. The parent will read from the pipe. Parent will read the test. The parent reading from the pipe, the child writing to the pipe, and the child will exit. So right now we are going to do the exercise. This is question 1. Write a program in C that fork 2 childs and wait for the 2 childs to exit. And then the program will output the exit status of both childs. So it says that we should have to fork 2 child. So here is toChild with fork and wait for the child to exit, and then program will output the exit status. First of all, we need to declare child1 and child2 as C1 and C2, and then RV1 will be the exit status of child1 and RV2 will be the exit status of child2. Here in the if condition, the child should equal to 0 if they need to be an output. However, here both of the child is larger than 0. So the parent process will be the output. The output parent, this is the parent process, will be done by the parent process. It will produce the PID by the get PID, and it will show both of its child PID. And then it will wait for the process to produce the exit status of both child. After both child exit, the parent will also exit. Else, if one of the child is equal to 0, which is true, for example child1, then it will produce the child1 process here. And if the child2 is the one that is equal to 0, then it will produce the child2 process. As you can see here, this is the parent process. It produced this output from this, and the child1 and child2 output, and the parent exit after both of the child produce their exit status. For question 2, we need to write a program in C that for toChild but only wait for one child to exit, and then the program will output the exit status of the waited child. The program runs just like the question 1, but we only need to wait for one child to exit, and just like question 1, we declare both child1 and child2, the child as fork, and if both child are larger than 0 or does not equal to 0, it is considered false, so it is considered as the parent process. And then here we can see it's different from the previous question. We only wait for one of the child to produce the exit status. So here we are using child1 as our child, as the child that we want to produce, and then the parent will display the child1 exit status. After that, the parent will exit as well. Here is the condition to allow only one child to exit. Just like question 1, we compare child1 and child2 to 0. Child1 is equal to 0, which means true, so it will produce child1 instead of child2, and it has its own PID. After that, it exits. Same goes to child2, but as we can see here, there is no exit output because based on this question, we are only asked to perform one child only. So as you can see, start from here until here, it only produced child1 process and the parent. It only display the child1 that is exiting because we only allow one child to exit. We have the information of child2 but does not show any output related to exiting. And for the last question, which is question 3, we need to write a file in C that will fork toChild. In the child, users are able to enter strings to write into pipe. Parent programs then will output the strings entered by users on both child. So in this program, we need to fork toChild, and then we will enter the strings to write into a pipe. And it says here we need to create 2 pipes for toChild. And then parent's program will output the string that are entered by the user. So first of all, we need to declare our variables. This is for pipe 1 and then this is for pipe 2. The value in this is somehow to indicate that two processes are happening inside the pipe, which is read and write. The chart input 1 and chart input 2 will be the variable that is used to allow the user to key in their strings, and this is the limit of the charts. If pipe 1 is false, then it will use fprintf to write the data into the file to tell that there is error message that is happening. However, if pipe 2 that is false, error message will be write into the file. And after that, as we can see here, the child process from the user to key in the string input. Same goes to child 2. So in order to write, we need to close the read, and the code for read is 0. So for child 1, if fork is false, then the process will perform everything that is set as the parameter inside the write process. After we write, we need to close, and then we exit. Else, for child 2 process, we need to be inside the parent process. The process will write the input by the user, and then it will exit. This will be how the file is going to be saved. This is for the buffer. The program will read the input of pipe 1 and pipe 2, and then we close the read, and after that, both of the child are able to turn the inputs by the user into output using buff. Here is the example. Enter string for child 1, and then child 2 will prompt the user to enter another string. The child 1 keep the data input by user. Both of the child are able to keep the data input by the user and produce it as outputs.